How's everybody? We are talking about the geometry of vectors today. And what does it mean visually to add, subtract, multiply vectors by scalars and things like that? Okay? All right, so for addition, how does this work? Suppose I give you two vectors in the same space. I'm going to draw them as if they're in the plane, obviously, because this is two-dimensional. But suppose I give you the vector u, okay? That's my vector u. And then I give you another vector v, okay? So another vector v. So let's say this is my origin, okay? Let's say this is my origin. I'm going to draw this in two-dimensional space, all right? So here's my origin. So I draw u, it points in this direction. And then I draw v, let's say it points in this direction, something like that, okay? There's v. And I want to make sense of what does u plus v look like geometrically, okay? So where is it in this picture? We know algebraically that if I take u plus v, I end up with something in R2 again, so that's great. But what does it look like geometrically? Now here's the trick. You take u, okay, and I'm going to take u plus v. So I'm going to take v, and I'm just going to take it and slide it over here. I'm not going to twist it. I'm not going to stretch it. I'm not going to turn it around. I'm not going to do anything like that. I'm simply just going to take v, and I'm going to take the tail of v and put it at the head of u, okay? So I'm going to get v over here. So I'm going to kind of draw this thing there, okay? So I'm going to draw that as just another representation of v. After all, a vector just points in a direction, at least vectors in R2 and R3. When you get to more advanced stuff, you'll find out that things like sine and cosine are actually vectors. We'll get there, okay? But if I take v as this arrow and I just slide this up to here and I put it right there, that looks like a pretty decent job, okay? So now what is u plus v going to be? All right, wait for it, okay? Wait for it. Okay, this is going to be u plus v, all right? That's the corresponding vector. U plus v is kind of this like diagonal of this parallelogram, if you will. Okay, now there's nothing special with me drawing this in the coordinate axes. I very well could have just said, okay, look, here's u, okay, there's u, and then I want to add v to it. So what am I going to do? I'm going to find v, I'm going to put v here, and then I'm just going to draw the corresponding thing, u plus v, okay? That vector going from the tail of u to the head of v is u plus v. That's what it is geometrically, okay? Now notice that this picture doesn't rely on this being inside two-dimensional space. I just drew the two-dimensional picture because we're more familiar with two-dimensional space and it helps us get some intuition for it and things like that. But these two vectors, like this u could live in R37, this could live in R37, and when I add the two, I get this corresponding vector u plus v in R37, whatever that looks like, okay? So that's what addition is. Let's look at subtraction. Okay, let's look at subtraction. Well, subtraction and addition are basically the same operation, right? You've kind of been lied to your whole life. You're told that, oh, they're different operations. It's like, not really, right? Because if I give you just numbers and I say, what is 5 minus 3? You're like, all right, if I have 5 things, I take away 3 of them, I'm left with 2 of them. Okay, great. So 5 minus 3 is 2. It's like, well, yes, but 5 minus 3 is really 5 plus negative 3. So the subtraction is really just addition of two different elements, if that makes any sense, right? Like what I'm saying here is if I take 5 minus 3, I can write that as 5 plus minus 3. So think about this in terms of vectors now. If I want to understand what is v minus w, okay, in terms of subtraction, then if I know how to add, then I'm going to write this as v plus minus w, just like I did here. And so all I really need to understand is what is negative of a vector. Okay, that's kind of the motivation for all this. So let's make this rigorous, okay, and see what this looks like. So this is subtraction, okay, i.e. addition of negatives to some extent. Okay, so the question that we want to ask, the question is, what does minus u look like? Okay, what does that look like overall? Well, let's give ourselves an example. Okay, so here's kind of an example. If I gave you something simple like u is equal to 1, 1, okay, then I could say, well, I know how to draw that because we know how to draw vectors now. So I could say I go over 1, up 1, so I'm going to draw that vector u. Okay, I'm going to draw that as 1, 1. which is the vector from the origin pointing at the point 1, 1. But if I said, okay, then what is minus u? Well, I say, well, how do I know how to do this? Well, this is really just minus 1 times u, right? And we know how to do scalar multiplication now, algebraically at least. It just says take the scalar and multiply each coordinate by that. So this is really minus 1 minus 1. And so minus 1 minus 1 looks like here's minus 1, here's minus 1. It looks like, oh, I'm drawing this vector here, that's just minus u. And if I step back, I say, oh, all I did was I just took u and I literally just turned it around. That's all I did. Okay? So that's the geometry of this. This is just, how do I say, kind of reflect u through the origin. Okay, that's not the most rigorous way to think about it. Okay, and I'm kind of being a little fast and loose with this question, with my wording on this. In terms of reflect, this is a very specific mathematical concept, which we'll get to, but basically like take u and just write it the opposite direction. That's what I want you to take away from this. Okay, so if I now know what minus a vector looks like, then I can say, all right, well, geometrically, what does u minus v look like? Okay, well, let's think about that. This thing is u plus minus v. Okay, so here we go. If this is what u looks like, okay, so here's u, and v looks like this, okay, that's v, all right? Well, then minus v just says take this v and flip it this way, okay, so minus v will be right here, so that's minus v. And then how do I take u plus negative v? I just take the corresponding tail to head there. So this would be u minus v. Okay? That's what u minus v is going to look like. All right? So what does this look like geometrically overall? Well, you could view it this way, but everything has to do with the parallelogram. Okay, so let me give you that. So if I gave you, here's the parallelogram. Okay, if this is u, that's u, and that's v, okay, then I can take v, remember I could slide it back here, okay, and get myself, this is v here, and I could take u and put that here. I'm doing my best, all right, it's on a chalkboard. This is supposed to be a parallelogram, okay, use your imagination. So u plus v is that term there, okay, so that's u plus v. Whereas the dotted is going to be u minus v if I'm pointing it in that particular direction. Okay? So there you have it. So we know that this side is u minus v, this diagonal is u plus v, and that gives you the intuition for how do I do addition and subtraction. The last thing we need is scalar multiplication. Okay? So for scalar multiplication, what does that look like? Honestly, all you're doing is stretching the vector or compressing it, depending on the scalar. Okay? That's all you're doing. So what does scalar multiplication look like? Well, we know how to deal with this algebraically. Okay? I have a previous video that talks about the algebra of scalar multiplication. But again, if I say, well, let's just do an example. If I again set u equal to the vector 1, 1, and I say, what is 3 times u? Well, algebraically, I know that this is 3, 3. I just multiply each component by 3. So what that says is that if I have something that is 1, 1, I've got this vector u, then I'm going to go out 2, 3, 2, 3, and I'm just going to say, well, that is going to be 3u. Okay? So notice that 3u is still pointing in the same direction of u. It's pointing in the same direction because 3 is positive. If I had said what is minus 3u, then this would be minus 3 minus 3. Okay, so what's that going to be? That's going to be this vector pointing down this way, so minus 3u. So now it's pointing in the opposite direction. So the sign of the scalar tells you whether you're pointing in the same direction or the opposite direction of the original vector. Okay? And notice that the magnitude, if you will, of that thing tells you how much you're going to stretch it to some extent, right? It's basically saying, look, if the constant is bigger than 1, you're going to take your vector and you're going to stretch it to be longer, okay? But if the constant, if I said something like 1/4 times u, well, that's going to be 1/4, and that's going to be tiny. That's going to be like this guy right here. Okay, so what did I do? I took u and I just shrunk it. All right? So really all you're doing is you're just taking the vector, you're either stretching it or compressing it, or you're turning it around and stretching it or compressing it. And that's all scalar multiplication is. All right? So you have any questions? You have any examples you want me to work out? Anything along those lines? After all, these are my office hours. Please ask, like, subscribe, all the good things, and we'll keep going.